In this C programming tutorial, we explain two basic methods for filling in array entries from the user input. Although this problem might look simple to more advanced students, the solution and correct implementation of this problem are not trivial. It is good learning practice to go through this problem. In this tutorial, we explain two basic solutions to this problem. Note that the presented solutions are not the most optimal ones and they are not very robust, taking into account that the user can enter a mix of different data types such as integer, floats, or characters. However, for people learning C, these solutions are good enough and they explain a number of interesting aspects of the C programming language. Here is the first problem that we will address in this video tutorial. A person first enters the capacity of an array that needs to be filled in. The array should be filled in until it is full. Write a C program that will ask the person to enter the numbers one by one. At the end of the program, the array entries are printed out. And here is the second problem, which is a variation and a more elegant solution to the first problem. A person enters a series of numbers without specifying upfront the total number of entries. To mark the end of the input, the user enters -1. Write a C program that will read a series of numbers specified by the user and that will store these numbers in the array. At the end of the program, the array entries are printed out. Before we explain how to solve these two problems, here are some very important notes. First of all, it's a good learning practice to learn how to compile the C code from the command line. For that purpose, we use the GCC compiler that is a part of the minimalist GNU for Windows, or MinGW, software development environment. We created a separate video tutorial explaining how to install MinGW on a Windows machine. A link to that tutorial will be given in the description below. To compile a C code file from the command line, we will use this simple command. That is, we will call GCC with these two options, vol and w, which will print additional compiler errors and warnings. Then we will specify the output, then we will specify the executable file, and we will specify the source code. This command will also print the compilation warnings and errors if there are any. Okay, let's start from scratch. First of all, let's open a command prompt. And over here in the command prompt, I will go to my C drive and I'm going to create a base folder for my two files and two solutions. I will call this folder test C. Then I will navigate to test C, and over here I will start my favorite C programming editor, and in my case I will be using Visual Studio Code. However, you can use any other C editor or C++ editor. I will start Visual Studio Code like this. I will click on yes, and let's create our first source file. Let's click on File, New File, and I will call the file as test1.c. Here it is, and let's start with coding. Let's go back to our problem once more. The goal over here is, first of all, to write a piece of code that will specify the capacity of an array. Then we should manually fill in the entries of this array, and finally we should print all the entries. To do that, we first need to include the necessary header files. Since we will be using printing and scan functions, we need to include stdio.h. Then I will include the second library, whose name is stdlib. I need this library since I will be using the malloc function to allocate the space for my array. And here's my int main function. Over here I like to return 0. Some people like to return -1, some people like to return 1, however I like to return 0. Okay, first of all, let's declare a variable that will store the size of the array. I will call this variable size. Then let's print the message for the user of this code. The message is enter the desired number of entries in the integer array. And over here, I will end the statement with this \n. This is actually a command, or better to say instruction, to C, for the C programming language to start a new line. Next, we need to read the value of size. To do that, we need to use the function scanf. So let's write scanf, and inside over here, we need to specify the format specifier. Since we need to read an integer, we need to use %d, and then we need to type this symbol, and then size. This will store the value that the user enters inside of size. And that's it. Next, once a user enters size, we can create our array. Now, a lot of people who are not experienced with C or programming will simply write something like this: int array, and then they will type size. Now, you might be able to compile this on some compilers. However, this is usually not a good practice. In my case, my particular compiler will create a warning or even an error, and you can see it over here. The issue is that this size has to be constant, and usually this is not a good practice to do. Instead of doing that, a better practice is to manually allocate the memory space for our array. To do that, we need to use the malloc function. I actually covered the malloc function in one of my previous tutorials, and I will provide a link to that video tutorial in the description below. The proper way of allocating the space is to do this. First of all, declare a pointer to the type of int, and then type this. Array, which is now a pointer to an array, is equal to integer with a star. This is the explicit cast operator, and then we need to type malloc, and then inside we need to specify the number of bytes that we want to reserve. Since we need to create an array of integers, we need to call size of int. Size of int is a very useful operator that will return the number of bytes necessary to store a single integer. In my case, it's going to be 4 bytes, and this will be for storing a single integer. Since I want to store an array of integers whose size is size, I need to multiply this by size. This statement is very important. So what's happening over here? Malloc function will return a pointer to void or void pointer, and it will reserve an appropriate chunk of memory. That is, malloc will reserve memory and return a pointer that will store to the beginning of the reserved memory space, and this pointer will contain the address of the beginning of the reserved memory space for our array. Then I need to cast this void pointer to be a pointer to integer, and that's why I'm typing this. The return address, that is, this statement will return address, will be stored in the pointer array. And then later on, we can use the standard notation for arrays. That is, we can type this to access the first entry, we can type this to access the second entry, etc. Keep in mind, array names and pointers are actually equivalent. Now over here, I need to type this: if array, then I will do something over here, otherwise I will do something here. Why am I typing here if array? I'm doing this since the malloc function might not be able to reserve the memory space. For example, memory can be full, and consequently array will become null pointer. That's why over here I'm asking basically if array is not a null pointer. If that's the case, we can proceed and we can read the array entries. Otherwise, we need to throw an exception or an error. To repeat, if array is equal to null pointer, then over here we will throw an exception. So we will type print f could not reserve the memory for the array, and then let's simply end this and let's return 1. That is, if we cannot reserve memory, we will simply exit the program and print this message. Okay, if we can reserve memory, over here we need to read the array entries. So let's learn how to do that. To do that, we will be using a simple for loop. So we will type for, and over here we need to specify our counter. The counter I will start from 0, then we will go until the size of our array, and then we are going to increment our counter. Inside, we will do this. We will simply type printf, enter the array entry number, and then over here I need to use this format specifier for the integer. Then I will type this, and then I will do comma I. And that's it. After that, we need to read the array entry. For that purpose, we will be using scanf. Then again, we need to use this format specifier for integers. And then over here, we need to read the entry of the array whose number is I. Simple as that. After we do that, we need to print the array entries. So let's do that. Over here, I need to type printf. Then I will type printing the array entries. And let's do a new line over here. And then again, let's use a simple for loop to print the array entries. I will type here for. Again, over here, I need to declare another counter. I will call it j. J should be smaller than the size. And then over here, we do j++. Here we simply type printf. The entry number format specifier for the integer is format specifier for the integer, and then new line. Then over here, the first integer that needs to be print is the counter j, and the second one is the actual array entry at the j location. And that's it. Simple as that. After we complete our program, we need to do this. We need to simply free the memory space that's reserved by our array. To do that, we need to type free array. This will erase all the entries in the array and free the memory space. If you don't do that, that is, if you simply call malloc without freeing the space, you're creating a memory leak. So you should always use the free command to free the space. And after that, let's set array to be equal to the null pointer. This is a good practice. And that's it. Simple as that. Let's save this code and let's compile this code. Although I can compile and run this piece of code directly from my Visual Studio Code session, I prefer not to do that. And I suggest to everyone to compile the file from the command line. Let's first locate our source file. It's called test1.c. To compile this source file, we need to use this command. Then we need to specify the output file. The output file name will be, for example, test1. And finally, we need to specify the source file name. Here it is. And this will compile our program. And if again list the content of my folder, I will see test1.executable. Let's run this file. And here we are. Now, what is happening is that Avast, that is my antivirus, for some reason opens this window which I don't like. So I will close this window and then the program will be able to be executed. So let's enter the desired number of entries in the integer array. For example, let's specify 5 over here. And then let's fill in the entry. Enter the array entry number 0. Let's put, for example, 1, 2, 3, 4. And this is the last one. Enter. And we can see the entry 0 is the entry 1, 2, 3, and 4. Perfect. So the code works. If you remember, at the beginning of this tutorial, I explained that I will teach you how to solve this problem in the simplest possible way. And yes, this is the simple approach, however, it's not robust. And let me show you why it's not robust. For example, over here, let's execute the code again, and let's specify, for example, 6. So what happens if I enter a character, for example, A? Look what happens. There is a problem. Although I need to enter 6 entries, I enter the character, and look what happened. And automatically it's even being printed. And there is an issue, of course. Our program is not robust enough and it cannot accept characters. In reality, you need to improve the robustness of this program by making several checks and several guards. For example, if a user enters a character, you should print an error, please enter an integer or a double or something similar. However, in the interest of making this video tutorial as short as possible, I will not explain how to do that. Next, in the same context, let's learn how to solve problem number 2. And here again is the problem number 2. A person enters a series of numbers without specifying upfront the total number of entries. To mark the end of the input, the user enters -1. Write a C program that will read the series of numbers specified by the user and that will store these numbers in the array. At the end of the program, the array entries are printed out. So what's the difference between this problem and the first problem? Well, in the second problem, we can enter the entries simply by just typing -1, -2, 3, 4, 5, -9, and a series of numbers without even specifying upfront how many numbers do we want to enter. For example, we can enter this. The code should read these entered numbers one by one and fill in the array entries on the basis of these numbers. And it should read the numbers until it reaches the end of array marker. This is -1. To summarize, this is a more robust approach for entering array entries. Here, we don't specify upfront the total number of entries, and the total number of entries will be determined and filled in during the execution of the program. Let's start with the implementation and with the solution. First of all, let's create a new source code. Let's call it as test2.c. And then over here, let's save it in this folder. Then, let's include the necessary libraries. First of all, let's include stdlib.h. Then let's include the std input-output.h. And although I said in the problem formulation that we will not specify the capacity of our array, it's still a good practice to define the maximum possible size of our array. And I'm going to do it over here. For that purpose, I'm going to use define preprocessor command, and then I'm going to define this constant max size. And I'm going to put the max size, for example, 10,000. I will explain the purpose for this later on. Then I'm going to define my main function. Over here, I'm going to return 0. And the first step that I will do to make my program to be robust is to declare an array. I will use this int array, then I will type max size, and I will type this thing. This will at the same time declare an array and initialize all the entries with zeros. Now, notice the difference between this type of declaration and the declaration that looks like this. For example, another way that you could try is this: int size 10,000, and then you can say int array size. As I mentioned previously, this will create a compilation error. You cannot do that because this size is not const, and it cannot be used like this. Instead of doing this, and to avoid the compilation errors, I am defining max size over here. And then I can type something like this. Next, let's define our counter. The counter is declared like this: unsigned int counter, and I will initialize it with 0. This counter will be used to count the current entry that needs to be entered. So let's print a message. Printf enter integers to fill in the array, and over here we can even print the message max number of entries is, and then let's use the percentage d. Let's put a new line over here, and we want to print max size. Good. Then after that, let's print the message printf enter -1 to complete the entry of entries. We can put like this, and let's do this. And then over here we can print f, this symbol, and new line. After this, the user can start entering the entries, and the user will type something like this. Actually, we cannot use -1, 2, 5, -5, 2, 3, 4, and to end the input, the user needs to specify -1. The first thing that we need to do is to read the first entry. We do it like this: scanf. We use the format specifier for integers since we plan to read integers, and over here we need to specify that we want to fill our array where the current value is specified by the counter. That's it. This will read the first entry. Now, we need to define a while loop that will read other entries. However, here we need to put a logical condition that will stop the entry reading in two scenarios. The first scenario is if the current entries that's being scanned is -1, and the second scenario if we reached the max size of our array. So let's type this: array counter, that is if the current entry that's being entered is not equal to -1, and counter smaller than max size. Then over here we perform this while loop. Inside of this while loop we are going to read the entry. We are going to type this. Then we will store the entry inside of our array. However, over here the current entry will not be simply counter, it will be counter +1, since over here we already filled in the first entry. And then after this we are going to simply increase the counter size. And that's it. After this, we will set our counter to be equal to 0, and we will use the same counter to print the array entries. So we will simply type this while array of counter not equal to -1. You're going to simply print the entries, printf, the entry, this integer specifier is integer format specifier, then new line, and then let's print the counter, and over here let's print array of counter. And after that, don't forget to increment the counter, and that's it. Simple as that, nothing special. This while loop will iterate through array entries until it reaches -1. The entry with -1, that is the entry that's equal to -1, denotes the end of the array. Simple as that. Again, let's save this file. Let's go back to the command prompt. Make sure that the file is over here, and then let's repeat the compilation. Over here, the output file will be test2, and the source file is test2.c. So let's run this. Here it is, no compiler warnings or errors. So let's run test2. Again, Avas will kick in. I'm going to close this window, and here we are. Enter integers to fill in the array. Max number of entries is 10,000. Enter -1 to complete the array, the entry of entries. Wow, let's start. So let's start 5, then 6, 7, 9, 0, -10, -15, and let's add -1, press enter, and here it is. The entry 0 is 5, it is. 1 is 6, we can see it's correct. 7, 9, 0, -10, -15. Perfect, works as expected. Let's do second test. Over here, let's just enter -1, and nothing happens. This is also good. Now, let's do a different type of test. Let's, instead of arrays, instead of integers, let's enter characters, or a mix of integers and characters. So let's start with 9, 5, 4. Let's enter H, A, B, and -1. And let's see what will happen. Bang, the program crashes. And you see what happens. Now, if I scroll all the way back, we can actually see what's the problem. Okay, we were able to read the first entry is 9. Then the second entry is 5, 4, and then let's see what happens over here. We can see that the third one is not being read properly. That is, this H, A, and B creates a problem. The code will run until 10,000 entries, and this is an issue. And this illustrates you a situation where this code will fail. There is a more elegant solution to this problem. However, in the interest of creating a short video tutorial, I will not explain how to resolve this problem. We will explain in our future video tutorials. Okay, that's all for today, and thanks for watching.